Okay, so we are going to do an application of logarithmic functions. This is actually one of the most common ways that we see it. The examples you're going to see if you get a logarithmic function question, they're going to be like actual real world kind of applications of them. So we have here, we know that in 1935, Charles Richter defined the magnitude of an earthquake to be m equals log of I over s. And if we have log with no kind of base written, that's log to the base 10. Like ln is log to the base e, log with nothing else written is log to the base 10. That's just because we use decimal, like a decimalized base 10 units of working for most things. Okay, so where I is the intensity of the earthquake measured by the amplitude of a seismograph reading taken 100 kilometers from the epicenter of the earthquake, and S is the intensity of a standard earthquake, whose amplitude is 1 micron, which is equal to 10 to the minus 4 centimeters. Right, so we've got an example here. So in the early in the century, the earthquake in San Francisco registered 8.3 on the Richter scale. In the same year, another earthquake was recorded in South America that was 4 times stronger. What was the magnitude of the earthquake in South America? Okay, so M is the magnitude of the earthquake, and that's kind of what we need to do, and that's measured on the Richter scale. So we can take our first bit of information. So if we have here, we know that it measured 8.3 on the Richter scale. That's the San Francisco one. Okay, so we can say that we know the magnitude of the San Francisco earthquake was 8.3. And we know that that was in fact equal to log, and we're going to kind of say that intensity was the intensity of the San Francisco earthquake divided by the standard one. Okay, other things we can take from this question. We got told that the one recorded in South America was 4 times stronger. So the South American one was 4 times as strong as the San Francisco. Okay, so we can kind of plug that into our equation as well to give us a different one. So we have the magnitude of the San Francisco earthquake was log, and then we've got 4 ISF over S. So it's 4 times the intensity of the San Francisco earthquake, and the standard earthquake thing kind of stays the same. So here it's just kind of manipulating our logarithms. So we've got MSF, that's what we want to try and find, and we have log of 4 ISF over S. Okay, so we need to kind of find something that we can replace in there. We have over here log ISF over S, which is kind of close to what we've got here, but not quite. And we've got a value for it, and that's what we're trying to do. We're just trying to get a value, so we're going to have to manipulate our logarithm until we get that. So if we do this, we can, because we know we're dividing, our rules of logarithm, that's the same as when we subtract. So we can say it's log of 4 ISF take away the log of S. So from there, we can expand even more. You have log 4 plus the log of ISF take away log S. Okay, so from here we can kind of manipulate it a little bit, and we know that this, if we do that, we're going to get a divide. So we're going to have it as log of 4 plus the log of the intensity of the San Francisco earthquake over the standard one. And then what we've got, the log of the intensity of the San Francisco earthquake over the standard one, we know that's in fact 8.3. So we're going to get log of 4 plus 8.3. We can just put that into a calculator, remembering it's log to the base 10. And that's going to give us 8.902, and then decimals after that, which we can round to being an 8.9. So you can see the Richter scale, whilst the earthquake was 4 times stronger, that doesn't actually give you a Richter scale value that's 4 times as high. It's only 0.6 higher on the Richter scale, even though the earthquake was 4 times as strong. and that's kind of how we know on the logarithmic scale. You can kind of see that that would be the case with knowing how a log graph works. Right, last thing to cover on logs and exponentials will be graphs where we have logs as our axes, and that's our last video before we're done with logs and exponentials.